the center of our galaxy, 26,000 light-years from where you are sitting right now, there is a black hole. It is not the largest in the universe. It is not the brightest. It is not even particularly active. It is simply ours. It has a name that sounds more like a coordinate than a place. Sagittarius A star, the compact radio source at the center of the Milky Way. The star was added because its discoverers considered the source unusually exciting, borrowing the notation used for excited atomic states. For decades, we suspected it was there. We watched the strange way stars at the center of the galaxy were moving. Some of them were orbiting something invisible at thousands of kilometers per second. Something dark, something enormous. In 2022, we finally saw it. A single image, released to the world after years of computation. A blurry orange ring with a perfect circle of darkness at its heart. That darkness is the silhouette of a black hole 4 million times the mass of our sun. And every star you have ever seen in the night sky belongs to the same galaxy-wide gravitational system, the system that Sagittarius A star sits at the dark center of. This is the quiet heart of the Milky Way. The story begins in 1974. Two American radio astronomers, Bruce Balick and Robert Brown, were studying the constellation Sagittarius. In the densest part of our galaxy, hidden behind clouds of dust that block visible light entirely, they detected something strange. A bright, compact source of radio waves at the very center of the Milky Way. It was unlike anything else they had observed. They named it Sagittarius A star, a designation that meant the brightest, most compact source in this region of Sagittarius. For the next 2 decades, nobody could say with certainty what it was. Some thought it might be a dense cluster of stars. Some suspected an exotic object we had never seen before. A few, quietly, wondered if it was a black hole. The problem was simple. We could not see through the dust. Visible light from the galactic center is blocked almost completely. To study Sagittarius A star, astronomers needed to use radio waves, infrared light, and X-rays, wavelengths that can pierce through the obscuring gas, and they needed to wait for telescopes powerful enough to do it. In the 1990s, 2 teams of astronomers, one led by Andrea Ghez at UCLA and one led by Reinhard Genzel in Germany, began the most patient observation in modern astronomy. They tracked the motion of stars at the center of the galaxy, year after year, decade after decade. Slowly, they built up a map. What they found was that the stars near Sagittarius A star were not moving randomly. They were orbiting something, tracing tight, fast ellipses around a single point. One of those stars, now known as S2, completes a full orbit every 16 years. At its closest approach, it passes within about 17 light-hours of the galactic center, traveling at nearly 5,000 kilometers per second, around 3,100 miles per second. Nothing inside that orbit emits light, but something inside that orbit has the gravitational pull of 4 million suns. By 2008, the case was effectively closed. The only object physics allows, that is that massive, that small, and that dark, is a supermassive black hole. In 2020, Ghez and Genzel shared the Nobel Prize in Physics for the discovery. We had inferred it for decades. We had measured its gravity to extraordinary precision. We had never actually seen it. That was about to change. In April of 2017, an array of radio telescopes scattered across the planet pointed at the center of the galaxy at the same time. It was called the Event Horizon Telescope, a globe-spanning network that, working together, could simulate a telescope the size of the Earth itself. What they were trying to do was until then, considered nearly impossible, to photograph the shadow of a black hole. The data took 5 years to process. Petabytes of observations had to be aligned across instruments separated by oceans. Tiny variations in atmospheric distortion had to be corrected for. Computers worked in shifts around the clock in laboratories on multiple continents. In May of 2022, NASA, ESA, and the Event Horizon Telescope collaboration released the result. A single blurry image, orange and yellow, a glowing ring of hot gas surrounding a perfect black circle. That black circle was the shadow of Sagittarius A star. The first direct image of the supermassive black hole at the center of our galaxy. It was almost exactly the size that Einstein's general relativity predicted. Down to scales of micro-arc seconds, Sagittarius A star is a supermassive black hole with a mass of approximately 4 million times the mass of our Sun. Its event horizon, the point beyond which nothing, not even light, can escape, is about 24 million kilometers across, or roughly 15 million miles. That is smaller than the orbit of Mercury. By cosmic standards, it is small. TON 618, one of the most massive black holes known, may be tens of billions of solar masses. Sagittarius A star is thousands of times smaller, but it sits at the heart of our galaxy. Our Sun orbits the center of the Milky Way at about 230 kilometers per second, around 140 miles per second. A single orbit takes about 230 million years. Since the dinosaurs went extinct, our Sun has not yet completed even a quarter of a single revolution. The galaxy turns around the mass of the galaxy itself. The stars, the gas, the vast halo of dark matter we cannot see. And at the dark center of all of it, quietly, sits Sagittarius A star. One of the strangest things about Sagittarius A star is how quiet it is. Most supermassive black holes at the centers of large galaxies are surrounded by enormous glowing disks of infalling matter, bright enough to outshine the entire galaxy that contains them. They are called quasars, or active galactic nuclei. Sagittarius A star is not one of them. It is feeding slowly. There are streamers of gas approaching it, sometimes captured, sometimes flung back out. Every so often, an unlucky star or gas cloud crosses its path, and astronomers detect a brief flare in X-rays or infrared. But by black hole standards, our central engine is dim. We do not fully understand why. Some models suggest the galactic center simply has less gas available to feed the black hole than other galaxies do. Others suggest that small black holes, like Sagittarius A star, feed in irregular bursts, and we are catching it during a quiet phase. What we know is that every few 100,000 years or so, Sagittarius A star likely has periods when it flares dramatically, bright enough to light up the entire galactic neighborhood for centuries. We may be living between two of those bright eras. There is one more thing worth saying before we close. In February of 2026, astrophysicists at the Institute of Astrophysics in La Plata, Argentina, published a paper suggesting that Sagittarius A star may not, in fact, be a black hole at all. In their model, the object at the center of the Milky Way would be a dense core of dark matter, a cluster of particles called dark fermions, particles that interact with the universe only through gravity and that resist collapse into a singularity. The object would still be 4 million solar masses, still bend light, still hold the stars in orbit exactly as we observe. But it would have no event horizon, and it would extend invisibly into the dark matter halo that surrounds our galaxy. One continuous structure, not two separate things. The mainstream view is still that Sagittarius A star is a black hole. The data we currently have cannot distinguish the two possibilities. But for the first time, There is a serious alternative on the table. There is a black hole at the center of our galaxy. It is not the largest. It is not the loudest. It does not glow across the cosmos like a quasar. It is simply ours. It has been there for billions of years. Sitting at the dark center of a galaxy-wide gravitational system that holds together every spiral arm, every star cluster, every star, including the Sun, in a slow, ancient orbit that takes more time to complete than mammals have existed. 26,000 light-years away, behind dust we still cannot see through with our eyes, there is a perfect circle of darkness with the gravity of 4 million suns. The Milky Way does not turn around it alone. It turns around the mass of the galaxy, with Sagittarius A star sitting at the dark center, the quiet heart of the galaxy.